Hey students, it's Miss Naras again. Today's video is about experimental probability. You have been doing experimental probability the last couple of days. You've actually been flipping the coin or rolling dice or spinning spinners, and you've been finding the chances of something happening based on those experiments. But in today's video, we're going to do a few examples where the information from the experiments is given to you in a table. So again, a reminder, the theoretical probability is the chances that something will happen based on the situation. And the experimental probability is what actually happened based on the experiments or the trials. And if you're lucky, the experimental will be greater than the theoretical. If you're unlucky, it will be less than what you thought was going to happen. Here's the first example. It says, based on the graph, find the experimental probability of spinning red. Well, I have the spinner right here. I see there's a 1 in 3 chance that I should get red, but that's not what it's looking for. It wants the experimental, what actually happened during the experiment. Okay, red. Let me see. Okay, well, we got red 24 times. So I know that the experimental probability, I abbreviated it, of red is 24 over something. But what's that bottom something? Okay, well, I need the total number of spins. It doesn't tell me anywhere. So I guess I have to add all three colors together to get my total number of spins. 21 plus 15 plus 24 gives me a total of 60 spins for my denominator. I could leave it like that, but I know that I should simplify fractions. And I simplified it by sixes, and then I simplified it by twos, and I got 2/5. I know that it's also, since it's 4/10, it's also 40%. Okay. Why don't you try to get blue and green on your own? You can pause the video now to do the math. Okay, hopefully you did do it and aren't just playing the video through to see the answer, but let's see what you get. So for the probability of blue, you should have gotten 1/4 or 0.25 or 25%. Any three of those answers is good. If you said 15 out of 60, that's an okay answer, but not as correct as if you simplify the fraction. And then for green, you should have gotten 7/20 or 0.35 or 35%. If you just wrote 21 out of 60, again, that's okay, but it's not as great. Notice what the percents add up to. So green 35, blue 25, red 40. Quick maths in your head. Oh, they add up to 100%. Let's do another example. Example 2 says find the experimental probability of spinning an even or a 1 after 22 spins. Okay, so different spinner, more complicated looking spinner. And it tells me an even or a 1. Okay. Then I look at my table. It looks more complicated because there's more sections in the spinner. But I know that it says after 22 spins. So I know that the probability of getting an even or a 1 is something out of 22 because that was my total number of spins. So I'm looking at evens or 1s. And if I read my table, number spun times spun. So, okay, so I got the number 1 twice. It landed on 2 3 times. Okay, so I want to look at the evens and the 1s, and I'm going to circle that. Well, I know my even numbers are 2 and 4, and 6 is even, and 8 is even. It said or a 1, so I'm also looking at 1. And now I have to figure out how many times each of those was spun. So I'm looking at these numbers on the side. So I'm going to add up 2 plus 3 plus 4 plus 2 plus 3. Quick math. I get 14 spins, and now I can put that in my numerator. You should know by now that I'm not going to leave it like that because I can simplify by 2. So I get 7/11ths is the probability, the chances that it lands on an even number or a 1, which is likely. That's it for experimental probability. I'll talk to you guys later. Bye.